Hello, welcome again. My name is Andy. I was a professional programmer for 20 years. Now I'm a lecturer. And here we talk about Python. We are learning Python for the humanities specifically. And today we want to talk about collections and loops. So we start with the question, why do I even need loops? Why do I need collections of data? Now, very often, if you think of practical applications of computing, it's about repeating the same action with different pieces of data. So, for example, you want to send an email to different recipients. You don't want to rewrite it every time. You write the email once and then you send it to this person and this person and this person. And so you have a list of people, a list of email addresses, and you send the same email again and again to every member of the list. Or you want to add a list of numbers, right? You have a bill, let's say in a restaurant, lots of numbers, you want to add them up to find the final amount. So again, you do the same operation, addition, to always a different number from this list. You add the first number and then the second and then the third. So this is a very common thing we do in computing, right? To use computer programs to manipulate lists of data and do the same operation on different members of the list. And specifically in the humanities, we often have lists of information. We have lists of ancient Greek philosophers, right? There's a collection of philosophers' names which are all ancient Greek philosophers. Or you have a collection of historical dates, the important battles of the Second World War, right? Is a list of dates and places. Or the lines of a poem is a list of lines, and then you can talk of each line separately. Or the words of a poem is a list of words. So you see, the concept of a list is very general and can be applied to many different things. And so the first thing we want to learn is how to make a list, how to manage a list. A list is an ordered collection that can hold multiple items. It's important that it's ordered. So when you say I have, let's say, the lines of a poem, you want to have them in a particular order. You don't want to just have a pile of lines and you don't know where they go. You want to know that's the first line, that's the second, that's the third line. So lists are ordered. They have a positional order. Inside the list, things are in a particular place. A list is something like a shopping list, a to-do list. It has a specific order. You can add or remove items, and you create a list by using square brackets, and each item then is separated by a comma. And if inside your list you have text items, strings, then remember to put the quotes around them so that Python is not trying to evaluate them. Okay, I'm looking around a little sometimes because I have to see the code, right, to remember what to say next. Okay, so here we go. Here you have an example, a list of key figures from the Renaissance. And this is your list now, right? Renaissance figures equals, and this equals, of course, is the assignment operator, is not equals. Strictly, it's not a test of equality, right? You remember the single equal sign is always an assignment. So we assign the list on the right side to the variable on the left side. Renaissance figures should be get the value. And now we have on the right side the value, which is now in square brackets our list. The square brackets tell Python that's a list. And now I have 4 different elements in there: Leonardo da Vinci, Michelangelo, Raphael, Donatello. And each one of those is a string that Python should not evaluate. Therefore, they are in these double quotes, and they are separated by a comma each. So this is my list. Now I have my list in this variable, which is called Renaissance underscore figures. The underscore is just part of the name. We do this often when we have multiple words in a variable name like Renaissance figures. You don't want to stick them together to make a very long word difficult to read. But also, of course, you cannot use dash because that's a minus, right? Then it would be a mathematical operation. So this is why I use this underscore to put these names together. Another list would be a list of important years, right? You have key World War I years, and then 1914, 1916, 1918. So that's a list of integer numbers as opposed to a list of strings which you had before. But the list works in exactly the same way. So it's just now a list of numbers instead of a list of words. And you can print the whole list at once in order to see it. So you would just saying print Renaissance figures, and then you see your list. Let's try this. Here we go. This is your list printed. You see it looks exactly the same like when you wrote it. So your code for the list in the first line of this program is exactly the same as the representation of the list Python gives you here. Why would Python display it differently, right? Doesn't make much sense. The only difference is here you have the single quotes for the words and we use double quotes. In this context, it doesn't matter. You can use either form of quotes. Okay, now we want to get out an element from the list, and there are various ways to do this. We can use a numerical index to get an element out of the list. For example, like you see here, print and then in brackets, Renaissance figures, and then again in square brackets, number 1. And now the question is, which is number 1? And you can try to guess, and I tell you already, it's not the first one. Why is it not the first one? Because by convention in most programming languages, there are a few exceptions, most programming languages start counting lists or arrays of data with 0, not with 1. So when I say, like I did here, print Renaissance figures and then in square brackets 1, which one do I expect to see? And let's go and see that. I will now go down here and execute it. And here we go. It's of course now Michelangelo, because 0 is Leonardo da Vinci, 1 is Michelangelo, 2 is Raphael, 3 is Donatello. And now let's go and look at how else we can access the elements of the list. We don't need to do it one by one. One by one is a little tedious, right? Because if you want to do something for all elements inside the list, then it would be, difficult to go one by one. In this way, you could do it. You could have a counter and then increment the counter. And in many languages, you have to do it. But Python makes it easier. It has a for loop that loops over all the elements of a list. So the for loop is designed to iterate or travel through a collection from beginning to end. A collection is a general term that includes lists. There are other kinds of collections, dictionaries, for example, but a collection is generally a kind of data type that contains different items, multiple items. And the core idea of the for loop is this is why it's called for each item in my list perform the specific action. And so the syntax of it you see here, for variable in list name, and then you have an indented block like with the if that runs for each item, and the temporary variable holds the current item so that you can do something with it. Now this might be a little hard to understand if you don't see the example. So here we have the example. Renaissance figures, and I have all these names, and then I print key artists of the Renaissance. So figure is my temporary variable for figure in Renaissance figures. Then I have indented part of the program. You see it's here, the indentation, right? This means that the for loop will repeat these lines that are indented there, right? And in every time when it repeats these lines, figure will take the value of one of the values of Renaissance figures. So the first time it runs, it will be Leonardo da Vinci, then it will be Michelangelo, and so on. So this will run 4 times because my list has 4 names, and each time figure will be one of these names. And then I print figure, and you see here this print f is an f string. You remember f strings, what they do? They print whatever is in quotes. So in this case, it would print this little dash character here, this little line, and then it would replace what is in curly brackets with the value of the variable. So in this case, figure. And figure, because of the for loop, will be a different thing each time the loop is run. In the end, it will print the loop is finished. So now try, please, before I run it, take a break here, stop this video, look at it, and try to tell me what will this loop actually print. How will the output look? Try to do this, try to think of it. Okay, you're back. So let's do it. Let's execute this. And you see it prints this little dash, then a space, because this is in the quoted F string, and then it replaces the figure. And because it's a print, the print automatically adds at the end of the print, adds a new line character, so you get everything in a new line, the 4 people, and then it says the loop has finished. So I hope you got the answer right. If you did not, then go back and listen again to F strings, what we had last time. Watch this again to make sure that you understand how this works. So how does this work? The for loop starts, it picks the first item, Leonardo da Vinci, stores it in the variable figure. It runs the print command, Python sees F, and then quoted dash space figure. Because of the F, it looks for the curly braces, it finds figure, it says I need to replace figure with the current value of the figure variable, prints the result, and then the loop runs again with a new figure, and it prints all these things. Okay, a string can also be treated as a collection of characters. So for loops work automatically in strings. When I say hello, this hello is not one monolithic word. It is in reality a list. It's a list of 5 characters, HELLO. And Python can automatically, without me needing to do anything, see every string as a list of characters. If I want, I can just use it as a list of characters. I can put an index and access the characters separately. So here I have a book title, Ulysses. I have a character count variable, 0. And now it says analyzing the title, and then with the curly braces book title. And this will be replaced, right, by the variable book title. And now the loop visits each character in this title for car means character, right? So it's a name of a variable. It can be whatever you want, but it's a good thing, we said, to use variable names that remind you of what it's supposed to be. So in this case, car is the character, for character in book title. And you see, I don't need to do anything. The book title is a string, but Python understands if I make a for loop over a string, I want the characters. And then it says found character and prints the character, and then increases the character count by 1. Now this increasing of the character count is a very common programming construct in all programming languages. You have to get used to that. It seems a little circular, right? When you see it the first time, character count is character count plus 1. If you are a mathematician, you say, of course not, right? How can it be that a number is the same number plus 1? But remember that this is not equality, we're talking about assignment. So the character count should be, we say, make it so that the character count on the left side is the old character count plus 1. So on the left side of the equal sign, of the assignment sign, you have the new character count. On the right side, you have the old one. And this effectively increases character count by 1, counts it up. And so for every character, when this loop runs, it counts the character count up by 1. And so in the end, it tells you total character founds, and you get the character count. So let us try this out. Again, it's most beneficial if you don't see the answer first, but if you first try to guess what it would say, and then we see if it does actually do what we want, what we think. So what would the output look like? Stop the video, think about it, look at the code, and then I will start it again. Okay, here we go. Let's execute it. Here you go. Analyzing the title, Ulysses, and then you have found character for every character, because this is in the for loop, right? You see print f found character, and because the print changes the line at the end of the line, right? We have it all in different lines, and in the end, total characters found is 7, which is the correct number. Okay, so before we continue, one brief part of Python syntax we have not yet talked about, and I think we need to know. how to call so-called methods on an object. And the idea is that you have different kinds of data, right? You know already we have strings, we have integer numbers, we have floating point numbers. And the point is that these are not as simple as they seem. When you see a string, you think, oh, it's just a string. But in reality, the string is an object inside Python that does not only contain the value of the string, those characters that make up the word, but it also contains functions that operate on this content of the string. So every string does not only have its data, but it also has functions that can operate on this data. And the same is true of integers. Originally, you say x is 42, you think that's just an integer, but in reality, there is a data part of it, which contains the number, but then there's also code inside this 42 integer that operates on this value 42 if you want it. So this is called an object sometimes in programming languages. An object is more than just data. It's data and code that are able to operate on this data of this object. And why is it like this? Why does an integer object contain functions, or why does a string contain functions? Because some operations only make sense if they apply to particular data types. Let's say turning a string into capital letters. Right? This is something that makes sense for a string, but I cannot turn a number into capital letters. This wouldn't make any sense, right? And therefore, the function that turns something to capital letters is part of the string object, but it's not part of the integer object. Integers have their own functions that don't make sense for strings. An integer might have a function to increment it by 1, for example, right? You have 4, you call the increment function, now you have 5. This wouldn't make sense for a string, right? How do you increment a string? Hello plus 1 is how much? Doesn't work, right? So these are examples of functions that apply only to particular data types, and therefore they are, as we say, encapsulated. They are within this string or integer object, and you cannot call them from the outside because it doesn't make any sense to call them from the outside. You would only create possibly an error by calling the wrong function with the wrong kind of data. And in Python, like in most programming languages, these functions are called, as you see here. The syntax is always data object dot and then the function. And sometimes you can pass the function some arguments that you need additionally for the function to operate. And this action, the dot action or the dot function, is part of the string object. So you call it inside the string variable. You give the name of your string variable, dot, and then the function, because the function is part of the string. So here's an example. Let's say we have a string. My name is Ada Lovelace. This is, by the way, one of the early pioneers of computing. And every string has a built-in method .upper that creates an all caps version of it. And so to use it, you would write my underscore name .upper brackets. The brackets are there just to show that we are calling a function. We don't pass it any arguments because it just turns the string into uppercase. It doesn't need any arguments. And so what you get is Ada Lovelace in uppercase. And all data types in Python have some of these methods that are useful for them. Some have many, many methods. Some have dozens of methods, like a string has lots of methods. And some of the most common ones is obviously, upper, which we already talked about, and lower to turn a string into lowercase. There's a replace method that replaces part of the string. You can say replace one word with another word, or starts with, which tests if the string starts with a particular word, with a particular sequence of characters. So, and that's all for this. Just mention it now because in the next example you will see this used, and so you should know what this is. Just remember it for the future. Whenever you see data type dot function call, this is a method of the object of this data type that you have there. There are shortcuts now for creating lists and managing lists, and sometimes you want to create a list by transforming items from another list. So let's say you have a list of numbers, you want to add a constant number to each one, or you have a list of prices and you want to transform them from one currency to another. You want to say, I have $5, $6, $7, and I want to transform this into €1, €2, €3, whatever euros they are that correspond to the dollars. And so I have to make the same operation on all members of the list and create a new list. And one way to do it, or here with uppercase names, in this example, you have the names of 3 writers and you want to convert them to uppercase. So I can do it. I can say I create a empty list uppercase name, right? An empty list I create by using, again, the square brackets without any content. And now for name in names, name is my temporary variable, names is my old list. I say for every single name, do the following: uppercase names dot append. And this dot append is a command of this list. What you need to remember is the lists themselves have code associated with them that is already given to you in the form of the standard Python library. So you don't need to do anything. A list knows how to do things, and it has a few verbs, right, if you want, associated with it that it already knows about. And one of them is append. So a list knows how to append things to itself. And what you're doing here is to say, take my uppercase names list and append what comes in brackets now. And what comes now is name, which is the name of the element, right, which we have here from our for loop, dot append. Again, this dot is again calling one of these functions that are associated with name. Name dot upper means convert the string to uppercase. So this way, every piece of data has a few functions, right, that are associated with it. A string always knows how to convert itself to uppercase or lowercase. A list knows how to append or how to delete items from it. And you call these actions, these verbs, these functions, by taking the name of your variable and saying dot and then the invocation of this function. So this now is appended to the new list. And so now we have a new list, which is uppercase names, and the output would be this here. We can, of course, try it if you want. Let's go there, execute it, and here we go. That's what happens, is exactly what you would expect. So look at it again. This is important because of these method invocations, that you have a piece of data and then dot, do something with it. Let's go down now. There is a simpler way of writing this, and this is called a list comprehension. This is just an easier way of doing what we just did, to copy one list, and while we copy it, we do something with every element. But it is a little confusing the first time you see it because it's written backwards in a sense, right? So the structure is now do this action, so the action comes first, for item in old list. And this gives you a new list, right? And this is called a list comprehension. So it's a compact way of writing this for loop that we just had. Let's try it out. There's a lot of explanation here, but we want to try it out. Here we have original publication years for particular works, and then we want to create a new list showing how many years have passed since each publication relative to the year 2025. So we have this publication years 1922, 49, 51, 1851, and 1913. And now we want the age of each book. And we do it with one of these list comprehensions. So look here, years ago is 2025 minus year for year in pub years. Again, I know it's confusing, right? It confused me very, very long until I got the hang of it, right? Because it's just backwards. but it's very compact and it does exactly what our loop did before. So there is an implicit loop in there. I mean, you see the 4, right? And the list around it means years ago will be a list, right? These are the brackets around it. And what is the content of the list? The content of the list for every element is 2025 minus year for year in pub years, for every year in pub years. So it will go through pub years, assign every year to this variable year, subtract the year from 2025 and assemble everything into a new list. And then we can print that. So let's try it out briefly. And here we go. This is what the output looks like. This is called a list comprehension. So I'm sorry if you find this confusing. Go back, look at it again and compare it with the previous example we had over here, where I had this long way of doing these things, copying one list and then assigning every element, compare it with this, and then you will see what we are doing and how this works. So make sure you are able to do this list comprehension and to understand how it works, because we will need it in the future. And with this, we are finished for today. Thank you. And next time we will talk about while loops. Thank you and goodbye.